Ho ho ho, and welcome to another day here on Try Hack Me. We are doing Advent of Cyber. It's day number 20. We are getting really close to the 24th, which it's going to be the very last day here on Try Hack Me doing Advent of Cyber. Today we are talking about network traffic analysis. Now, doing network traffic analysis is done with a program called Wireshark. Wireshark is a program that can intercept, parse, and in a, I would say, beautiful way, show your data very organized. This is a picture of Wireshark showing you traffic. There's a number on a package, time, source, destination, protocol, links, info, and so on. All the fields are easy to customize, and what you see here up in the top is what is called the filter, where you can apply filters. In this particular example, we only want to see packages from this particular IP address, ip.source. Now, when you type IP and a dot, actually options gonna pop down in most occasions, at least the version that I tried in Wireshark. So they talk about different kind of things here in Wireshark. They do talk about something about outbound traffic and inbound traffic. Now, there are some things we can do to help us to verify traffic, but I suspect in this particular tutorial, we're gonna go ahead and open up the EC2 traffic analysis. So I guess we're gonna double click on that file, because this is the file that we're going to perform analysis on using Wireshark. Okay, so what are the questions we need to answer? The very last question is, we can always learn more about Wireshark. Let's check that out. What is the first message the payload sent to media malware's control server, command control C2 server, right? What is the IP address? What was the command sent by the C2 server to the target machine? What was the file name of the critical file extracted by the C2 server? And what secret message was sent back to the C2 in encrypted format through beacons? So there are different ways to go ahead and check out the traffic, and we have it right here. Let's just check out where we have the first package in the top, and the bottom package is in 1920 different packages. Now we are mainly seeing what is called blue traffic right here, which is TCP. You can also see TCP popping up everywhere. Sometimes it will change color depending on the type of package, and that was something right there. For example, there's a type different kind of package there. Most of it is still TCP. We're just checking out if there's any HTTP. That's usually marked as green, by the way. So you can also filter that. You can actually click these headers up here to filter. But we do see that there are some it's actually a request right here for sending a message to /beacon, and we can always click those packages, and there are different windows here in Wireshark. I want to be 100% honest with you. The one to the right here in the bottom with all the numbers, it's just a hexadecimal view of the things that is over here and organized. So if we're, for example, pressing this one right there, you can see like there's something called the line-based text, which is also going to be marked over there as the actual text that is being sent. You can see that if you click this here, it does say encrypted. The extracted file has a clue. So there's a pretty good chance that this is actually sent using a encrypted HTTPS protocol. And if you check up in the top here at the post, you can see HTTP, and open this right here. You can further investigate whether it was not sent using HTTPS. or HTTP just, and you can see that it's just the HTTP type protocol, so it should not be encrypted in any way. You can also see some host IP address and some port and different kind of things, and I'm just basically, giving you a head start that if you click these kind of things here, the different fields, it will also be marked over here, which is gonna tell you that the word post is 54F5354 in hexadecimal. If you want to do it, you can just pull this all the way over there. Maybe just leave it there so you can always pull it back, because in most occasions we're not really going to need to see the hexadecimal view of the data. It is just usually a waste of time. It is also pretty small, the text here. We can always try to go to File, and we can check out the... where they usually save these kind of things. Edit, View maybe, and then somewhere we can probably zoom in this. Let's see, Preferences maybe. And then do fonts and colors, and we're gonna go ahead and check out a bigger font so you can see it. Let's say 14, and apply. So I guess the data is a tad bigger now. I'll have to scroll a bit in order for me to, have all the data in one window. So there's also a mention of CyberChef, which is a website that can help you to encode, decode, and different kind of things, sort data for you. So probably going to use that at some point. So what you're going to do now is go ahead, and it's a pretty small tutorial, so I just took my time to get you started right here. So now that we have a better idea of the C2 traffic looks like and how we use Wireshark, double-click the C2 traffic analysis in the desktop. We just did that. So now we are beginning, and we are at packet number 1. This will automatically open the PCAP file using Wireshark, which is true. The traffic, yes. So we always suspect that the machine is compromised. So let's narrow down our list so we only show traffic coming from the IP address of Martha Mayware's machine. To do this, click display filter, and I'm going to put in this filter right there. So we're being handed the IP address of this particular person. So pop it in, press enter, and now we're only seeing traffic from a particular person's machine, which is actually the same kind of amount of packages as before, which is very interesting. Anyways, still a lot, but at least we can focus on our analysis. Let's one more time just check out if we got anything wrong. It's maybe I didn't click. Well, I think I did. Yeah, it's all the same. As you can see, the source address 10.10.229.217. That's all the same all the way down, so it's gonna be fine for now. If you scroll down a bit, you will find some interesting packages, especially those highlighted with the arrow as shown above. So what we can do is sort it by protocol, for example, and then you're going to see the TCP. You can also click it again to reverse the sort. And in the top somewhere, on the bottom somewhere, it's going to be all the mentioned, at the bottom right there, HTTP traffic. And we can probably, turn that around by just going to the top, press it one more time, and go to the top again, and there you have it, all your HTTP traffic. There's also ways only to show HTTP traffic up here, for example. I think you can basically just type HTTP, press enter, and then you're seeing all the different kind of HTTP traffic, and there was actually more than we just saw before. But that was because we sorted out some traffic, so we're seeing more packages than only this particular IP address. Now, when you click a package right there, we can see that this particular IP address sent something to that destination, and that destination, if you look at the left hand here on the number, there's an arrow saying outbound, and this is inbound traffic. So we're actually sending, and we're getting a ping back from the server, which is all the same destination IP address. You can see the destination IP address is now the source IP address, and the source IP address is now the destination IP address. So the sender is now the receiver, and vice versa. But that's actually response. So those packages are, together. So we can click on them, and in most occasions they're going to be pretty much tied up, but sometimes they can jump and have different lines, but it doesn't seem like this occasion right here. So let's just go back to the filtering of the address. So we have this particular traffic right here, and we can see that this particular person did actually visit interesting path sources on a web page, initial command, exfiltrate, and something with beacon. We don't really know what that all just means right now, but we'll continue on the tutorial. This is also what it shows right there. So message received. Now if you click on the post initial, so let's do that, post initial, the first package, and we can always just drag these up a bit here so we have more space to analyze the data of this package. We see that, let me just fold everything together so we don't, see more than we should, right? The packet frame 440, more details were shown, the button pans, so it's the panels that I already talked about. The one here and the one we put to the right. Those panels or pans will show more detailed information about the packet frame, which have relevant details such as a frame number, the destination IP address, and more. You can expand each detail if you want, but the critical area to focus on is the byte, packet byte panel. So we can, okay, so they want us to check out this right here. Okay, so let's say I am the mayor, and they want us to check it out right here on the other side and see like this is the packet byte, but it contains the same thing, so it doesn't really matter where you look, but it does say I am the mayor. So that could be a message, since it's sent to the server, we can suspect that maybe this is the thing that the command control server, the CISO server, is receiving and can actually react on. Now what we can do now is what we're going to talk about is called something called follow. So we're going to read the text. The screenshot above shows something interesting. I am in mayor. Displays a text relevant like to us. If we right click the post initial packet frame and select follow HTTP stream, a new window will pop up and show us the forthcoming package. We can right click right there and say follow an HTTP stream, and what we're going to see here is actually what is being sent to this package. So we're following the traffic by actually saying let's see what the response was to this package, which is the request right here and the response in blue, and we're getting the word back called perfect. We can see the server is something called base HTTP version 0.6, and it's a Python 3.8.10 version. So it's something, probably just a Python server running back in using HTTP 1.0. It's very basic, so we're gonna suspect it's pretty bad, most of it. Okay. This feature is useful to view all the request and response between client and server, which is of course true. But let's not stop here. Other interesting HTTP package was sent. If you follow the HTTP stream of the get command, let's close it down. And I want to say something now. Now that we pressed get, follow, sorry, you should see the top here. It changed, so it says TCP stream equal to 1. So basically, it now shows us the traffic that is a part of that we just saw before. So let's paste the original filter back, and now we're gonna get the get command. Get command is something that usually gets us something. We can click it and usually just click the hypertext transfer protocol and see that, well, it's just a get. There's no variables. That's also going to be a part of the URL right there, which is what get stores its arguments or variables. We can see the host and the IP address and the port. What we're going to do now is right click it and say follow an HTTP stream, and then we're going to get here is a response back called who am I. So basically something is going on here which is a bit weird and fishy. We have no really clue what this is all about, but it's definitely something that is crazy. So, and the tutorial is now talking about You see the request of the same IP address. The reply came back from the command commonly used in Windows and Linux system to display the current user information. Yes. The communication suggests that the destination is attempting to gather information about the compromised system. A typical step during an early reconnaissance stage, which is exactly what it is. So, usually the reply from C2 server contains the command instructing the malicious program what to do next. However, the type of instruction depends on the malicious actor configuration, intents, capabilities. So there are different kind of things we could do, like getting information, executing commands, downloading stuff, and exfiltrating data. These are different kind of actions that could be done instead of this command right there, which is harmless, of course, but still, exfiltrating the actual user running on the system. So if we follow the HTTP stream exfiltrate, so let's go back, put in the original filter. I have it in my copy paste, it's easier. It's going to be the other post command right there. Click follow HTTP stream. Now we can see that something is being sent. Post request usually send data. This is the URL is sent to. As a content length, all this doesn't really matter. What really matters is what is packed in between these funky lines right here in the top and the bottom. It's a content disposition. It's some data. It's a file. It's called credentials.txt. And this is pretty bad because it probably contains some data that we would like to steal. So we're just getting the ping back data received. That's pretty bad. So. Okay, so we're going to find some clues to the file inside. If you check the rest of the PCAP, you're going to find more interesting package recaptures. Let's break down. So what's in the beacon, right? A typical C2 beacon returns regular signal updates from a compromised machine to the C2 server. The beacons may be sent after regular or irregular intervals to the C2 as a heartbeat. Here's how the exchange looks. So there's a description of that. It's interesting enough, but something that we're not gonna, spend too much time looking into right now. In this scenario, major malware agent payload inside Martha Mayweather's computer has sent a message that is sent inside all the beacons. Since the content is highly confidential, the secret agent encrypts it inside all beacons, leaving a clue for major malware to decrypt it. We can identify the beacon by the multiple requests sent to each server from the target machine after a regular interval of time. The exfiltrated files content hints at how these encrypted beacons can be decrypted. Using the encryption algorithm with the provided key, we now have a potential way to unlock the beacon messages and uncover the major malware's agent is communicating to the server. But what exactly I'm about to reveal? So, yeah, since the beacon is now encrypted and you have the key to decrypt it, do we have the key to decrypt it? I think it's very funny that they say we have the key. Where's the key? Have I missed it? Anyways, let's just continue and see if we're gonna get the key. Maybe I just missed it because I'm pretty tired. Sorry for that. So the CyberChef tool would be a source of truth for some of the mystery because of its wide features. It is considered as a Swiss Army knife, which is true. We can use this tool for encoding, decoding, encrypting, decrypting, hashing, and much more. However, considering this task scope, we would only cover the decryption process using this tool. The link, click it, will open the CyberChef tool in your browser. From the tool dashboard, you will be utilizing the following pans for decrypting the beacon. So, in operations, recipe input and output, these are the things they talk about right there. We're going to search for AES, decrypt, and drag it into the recipe area. So, we're going to type AES, AES, decrypt, and there. Now we do need a key. So Recipe. This is the area where you select the mode of encryption. So we're gonna say ECB and enter the decryption key you have. Keep the other options as they are. So we would definitely need the decryption key, which we have right here. So let's copy paste that and put it in right. I think it said ECB, didn't it? So recipe, ECB, so the mode is ECB. And if we forget anything, this is the area where we could select the mode of encryption, ECB, and enter the encryption key that you have. I think we're just gonna put it right there. So now it's green, it's happy. Once the recipe is done, it is time to enter encrypted beacon, our encrypted beacon into the area, copy your encrypted string and paste it there. Now, okay, so let's go back and say, I want to see, so there are ways to see apply as a filter. So we're going to say selected, I think it is. Yes, so now we have the same again. We have one beacon right there. Let's, just take it, and you have some encrypted text. We can right click it and say copy and then say value. Go back here, the input, remove whatever we don't need. And then we have it, the first one. So let's go ahead and continue doing the other ones. Copy. Right click, sorry, copy. And then value, and we just copy paste it in. Sorry for that, there we go. Let's take all the others while we add it. So there, copy paste. And value, probably an easy way to do this, but I'm gonna do this. Can we just copy right there actually, or just try? No, we would need to, is that the same thing twice? Let me just see. This is where the copy paste issues is showing us it is actually the same thing, all of it. So we could basically just take this one right there, I guess, and copy paste it. I thought we were going to get a flag. Anyways, was this one the one there? Oh, it's slow. Yeah, so that's the correct answer for that question. So what was the first message? This is the initial one right there. It says I am the mayor. So right click, copy, value, paste it in, submit. Now, what was the IP address of the C2 server? Well, we have it right there. We can just go and type it. So 10, 1, 2, 3, 1, 2, 3, yes, 2, 2, 4, if I'm not mistaken. And what was the command sent by C2 server to the target machine? It was who am I, as we saw before. And what was the file name? It was called, I totally forgot that. So right click on exfiltrate again, follow an HTTP stream, and it's called credentials. So go ahead, copy paste that, paste it in, and we're basically done. No, so I really hope that, going through this step by step gave you a better idea on how to do, standard data exfiltration using Wireshark. It does require you to have the actual file on your machine in order to file containing traffic. So if you have, for example, let's say a Wi-Fi access point, and you are connected to it, and you have a Wi-Fi adapter, and it can run in monitor mode, aka promiscuous mode, then basically you can interact with the traffic and see what's being sent around you in the air, and you can intercept, people's data. And if they are communicating with a server that is not using, TLS, HTTPS as for secure or for encrypted traffic, well, then you can basically read everything they do in clear text, and this is pretty bad. So Wireshark is a beautiful tool to intercept traffic and also put it on the network. So if you have, let's say, a lot of machines and all the traffic goes out of a switch, you can just put a computer at the other side of the switch with Wireshark, and you can just record the traffic and see what is going on, because you have all the IP addresses and the MAC addresses of, and it's most important with the IP addresses, but anyways, as I told you, all the traffic will be recorded in something called a PCAP file. You can analyze it in Wireshark. Wireshark is a beautiful tool. I have tutorials about Wireshark on my channel as well, and I will link to them in the description below if you want to learn more about Wireshark. So only one thing left to say is